Hello guys, welcome back to my channel. My name is Manas Adhikari and I'm 10 years old. So in today's video we're going to solve a differential equation x plus y times y prime is equal to x minus y. Before we get started, please like and subscribe to our channel and share my video. Now let's get into it. So first we're going to divide by x plus y on both sides. So I get y prime is equal to x minus y over x plus y. So now I have y prime is equal to, now I have to make this into a function of y over x, and in order to do that we have to divide both the numerator and denominator by x. So we get 1 minus y over x over 1 plus y over x. So now I'm going to use substitution method, so I get v is equal to y over x. So y is equal to vx, which means that dy dx is equal to v plus x dv dx. So now we get v plus x dv dx is equal to 1 minus v over 1 plus v. So now let me erase this, and this. So now I subtract by 1 minus v over 1 plus v on both sides. So we get v minus, let me erase that. So we get v minus 1 minus v over 1 plus v is equal to negative x dv dx. So now I know that v is same as v over 1, and the least common denominator is 1 plus v. It is times 1 plus v, and this times 1 plus v. So now I get 1 plus v times v, which is v squared plus v minus, parentheses, 1 minus v is closed all over 1 plus v is equal to negative x dv dx. So now let me erase this, and this. So now I have v squared plus v minus 1 plus v over 1 plus v is equal to negative x dv dx. So now let me erase this, and this. So now same as v squared plus v, which is 2v minus 1 over v plus 1 is equal to negative x dv dx. So now we know it is a separable differential equation, so the same as dv over v squared plus 2v minus 1 over v plus 1 is equal to negative dx over x. So now let me erase this, and this. So now same as v plus 1 dv over v squared plus 2v minus 1, and that is equal to negative dx over x. So now let me erase this, and this, and this. So now we take integration on both sides. So we'll get integral of v plus 1 dv over v squared plus 2v minus 1 is equal to, we know the integral of negative 1 over x dx is negative ln absolute x plus c. So now we know that in order to find the integral of this, we're to use u substitution. So I'm going to make u equal to v squared plus 2v minus 1. So now that means that du is equal to 2v plus 2d. So now that means that du over 2 is equal to v plus 1d. So now let me erase this, and this, and this. So now we have integral of v plus 1 dv, which is du over 2, so we can take out 1 over 2. We have du over u is equal to negative ln absolute x plus c. So now same as we know the integral of 1 over u du is ln absolute of u, so closed, over 2, and that is equal to negative ln absolute x, so closed, plus c. So now let me erase this, and this, and this. So now we have ln absolute of u, which is v squared plus 2v minus 1, absolute closed, over 2 is equal to negative ln absolute of x plus c. So now I'm going to erase this, and this. So now we're going to cross multiply, so we get ln absolute of v squared plus 2v minus 1, absolute closed, is equal to negative 2 ln absolute x plus, we know that 2c is the same as the constant c. 1. So now that means that absolute value of v squared plus 2v minus 1 is equal to e to the power negative 2 times ln absolute x plus c. 1. Bring this closed. So now let me erase this, and this. So now that means that v squared plus 2v minus 1 is equal to e to the power negative 2 ln absolute x, absolute closed, times e to the power c. 1. So now same as we know that v is equal to y over x, so y over x squared is y squared over x squared plus 2y over x minus 1 is equal to, we know that e to the power c1 is the constant. Okay, and now we have e to the power negative 2 ln absolute of x, you're saying as x to the power negative 2. So now let me erase this, and this. So now we're going to multiply by x squared on both sides. So we get y squared plus 2y x minus x squared is equal to, okay, times, you know the x to the power negative 2 times x to the power 2 is 1, so we're going to leave that. Now let's find the s. So thank you guys for watching my video today.